Good day, everybody, and welcome to our Mathematics 9 class. Today, we are down to the last lesson for Chapter 6, and it's about theorems on right triangles. We start by reciting today's memory verse. It's found in 2 Corinthians, verse 3, chapter 3, verse 18. It says, "And we all who with unveiled faces contemplate the Lord's glory are being transformed into his image with ever-increasing glory, which comes from the Lord, who is the Spirit." Your VCA Boosters today is about the Wisdom Pyramid. Brent McCracken presented the Wisdom Pyramid. You see here, it shows that we can get the most useful wisdom from the Bible. And the tip is in social media, the least useful tip source. Based on the diagram, this shows us that our Bible is our main source of wisdom. You need to make your own slogan or quote. It must be original to remind us that the Bible is our main source of wisdom. At the end of today's class, you'll be able to do the following. First, prove the Pythagorean theorem. And second, apply theorems on right triangles. Let me introduce you to Pythagoras. Based on the name Pythagorean Theorem, the one who is associated with that is Pythagoras. The Pythagorean Theorem has long been associated with Greek mathematician and philosopher Pythagoras. However, the theorem is believed to have been far older than Pythagoras. Pythagoras was born around 570 to 500 BCE, while the theorem was first seen in 1900 to 1600 BCE in 4 Babylonian tablets. It is a very accurate calculation of the square root of 2. A list of Pythagorean triples is also seen. The theorem is also mentioned in the Bodhayana Sulbasutra of India, written between 800 and 400 BCE. Nevertheless, the theorem came to accredited to Pythagoras. It is also a proposition number 47 from book 1 of Euclid's Elements. So this is Pythagoras. Now let's start with the Pythagorean theorem. Now, what is the Pythagorean theorem? The Pythagorean theorem states that the sum of the squares of the legs, if you see this triangle, that slanting part is called the hypotenuse, while these two that's forming the right angle are called legs. The sum of the squares of the legs of a right triangle, that's a squared plus b squared, is equal to the square of the length of the hypotenuse, that's equal to c squared. So if this is a right triangle, then the Pythagorean theorem applies that a squared plus b squared is equal to c squared. Now here's a proof of the Pythagorean theorem on how to get the area of this small square. The area of the small square is equal to the area of the large square minus the area of these 4 triangles. And you'll get the c squared equals a squared plus b squared. Now let us try solving this right triangle. We'll be looking for the missing leg or the missing hypotenuse. Find A if B is equal to 21 and C is equal to 29. So base here, B is 21, C is 29. And we are looking for the value of A. So let's start solving. Sorry, I don't have my pen, so I will just use the caret sign to show you for the squares. Now let's start. Ready? Remember that c squared is equal to a squared plus b squared. So our C is 29. That means 29 squared is equal to A squared plus our B is 21. It's 21 squared. Now 29 squared is equal to 841. Is equal to A squared plus plus 441. Now we transfer 441 to the other side. So we have 841 minus 441 is equal to A squared. We are left with 400 is equal to A squared. Now this time, we need to find the value of A. So square root of both sides. It means you need to have a square root for 400 and also the square root for A squared. The square root of 400 is plus and minus 20. But since we're dealing only with measurements, we just take the positive measure. And the square root of A squared is A. So we say that the value of A is equal to 20. If you're going to check that, then we'll have 29 squared is equal to 21 squared plus 20 squared, in which 841 is equal to 441 plus 400. Thus, our left-hand side is equal to the right-hand side. So our A is equal to 20. Let's go to the next number. For the next one, find C to the nearest hundredth if our B is equal to 7.1 and our A is equal to 4.1. So we're looking for the value of C. Remember the Pythagorean theorem. It's so easy to memorize this. Our Pythagorean theorem that C squared is equal to A squared plus B squared. Our C is missing. Our A is 4.1 squared. Our B is 7.1. Then we square it. Our C is still missing. 4.1 squared is equal to 16.81. While 7.1 squared is equal to 50.41. We add them, these two, we will get 67.22. But again, we need to find the square root of both sides. Square root of C squared is C, while the square root of 67.22 is 8.20. Or we can just say it's approximately 8.20. That's the value of our C. Now let's go to B. I've skipped that one here. Find B. Find B if A is equal to 3, C is equal to 5. So we're looking for the B, the value of B. Now let's write again our Pythagorean theorem. Again, the Pythagorean theorem only applies to the right triangles. C squared equals A squared plus B squared. Our C is 5. That's 5 squared is equal to 3 squared plus B squared. 5 squared is 25. 3 squared is 9 plus b squared. We transfer 9 to the other side, this one. So 25 minus 9 is equal to b squared. So we have 16 is equal to b squared. We find the square root of both sides. The square root of b squared is b. The square root of 16 is 4. Therefore, the value of b is 4. So you have 3, 4, and 5. If you have questions on this subtopic, feel free to message me in Telegram. Let's go to the next one. Let's have the converse of the Pythagorean Theorem. If in a triangle, the square of the length of the longest side is equal to the sum of the squares of the lengths of two shorter sides, then the triangle is a right triangle. So for example, if C is the longest side and you will square that, and it has the same answer as the square of A and the square of B, then that will be a right triangle. In exercise number 2, we determine if the given measures are lengths of the right triangle. So again, how will we know if these are measures of a right triangle? It's when the measure of the longest side, you square it, is equal to the sum of the squares of the two shorter sides. Here, our longest side is 15. It's going to be 15 squared is equal to the two short sides. 9 squared plus 12 squared. 15 squared is 225, while 9 squared is 81, and 12 squared is 144. If we add 81 and 144, we'll get 225. Therefore, these are sides of a right triangle. Let's go to the next exercise. 3, 4, and 8. Again, 3, 4, and 8. Actually, based on this given, these could not form a triangle because if you'll add 3 and 4, you'll just get 7, right? And the sum of the two sides must be greater than the third side. So it will never form a triangle. But if you want to use the Pythagorean theorem, you have c squared equals a squared plus b squared. Our longest side is 8. We square that. Equals 3 squared plus 4 squared. So we have 64 plus 9 plus 16. Once we'll add 9 plus 16, that is 25. So we say that 64 is not equal to 25. And with that, we say these are not sides of a right triangle. That's it. Let's go to the next one. A 13-foot ladder is leaning against a wall. The ladder is 13 feet long and it's leaning against the wall. The base of the ladder is 5 feet from the wall. The question, how high up the wall does the ladder reach? We didn't know how high is this wall where the ladder is reaching, so you'll just name it as X. So we say, let X be the height of the wall reached by the ladder. If you see, this is forming a right triangle. So c squared is equal to a squared plus b squared. Our c here is the length of the ladder. That's going to be 13 feet squared equals Our A can be our X. So X squared plus the other one, 5 feet squared. So we now have 169 feet squared equals X squared plus 25 feet squared. We transfer 25 to the other side. Is equal to X squared. So solving on the left side, that's 169 minus 25. We will get 144 feet squared equals X squared. Now we find the square root of both sides. We have X squared, the square root is X, and of 144, the square root is 12. Of feet squared, the square root is feet. So the length, the height of the wall where the ladder is being reached is at 12 feet. If you have questions, feel free to message me in Telegram. Now let's go to the next subtopic. The next subtopic is about the Pythagorean triple. Now, what is a Pythagorean triple? A Pythagorean triple is a set of 3 natural numbers, A, B, and C, that satisfies the equation A squared plus B squared equals C squared. For example, 9, 12, 15. This forms a right triangle. So this is a Pythagorean triple. Now we show that 3, 4, and 5 is a Pythagorean triple. How do we do that? It's just the same as the one in the triangle. But C squared equals A squared plus B squared. Again, C is the longest side. That's 5 squared equals 3 squared plus 4 squared. Of 25 was 9 plus 16. So 25 is equal to 25. Thus, 3, 4, and 5 is a Pythagorean triple. Let's have another example. Show that 20, 21, and 29 is a Pythagorean triple. Again, it's based on the Pythagorean theorem. C squared equals A squared plus B squared. So we have 29 squared equals 20 squared plus 21 squared. 29 squared is 841. 20 squared is 400. 21 squared is 441. Therefore, adding on the right side, we have 841. So the left side and the right side are equal. See, thus 20, 21, and 29 is a Pythagorean triple. Any questions? Let's go to our next activity. We will have an observation activity. And here's what we'll do. Count the number of units for each side of the given triangle. Then square its sides. Complete the table below. Let's try counting. Remember, this one is a right triangle. So we count the height. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5, 6. Next, 1, 2, 3, 4, 5, 6, 7. Check. 1, 2, 3, 4, 5, 6. It's still 6. The other one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. It's just 6. 1, 2, 3, 4, 5, 6. This must be 8. Base here. It's maybe they missed some. But the other? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, right? 1, 2, 3, 4. The other is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is an example of an obtuse triangle. The last one, 1, 2, 3, 4, 5. 1, 2, 3, 4. The other is 1, 2, 3, 4, 5, 6. Okay, so let's have obtuse son. The shorter sides are 6 and 4. The longest side is 9. So we square them, 36 and 16. The sum is 42, 52. The square of the longest side is 81. Is it correct? Next, for the acute, the short sides are 4 and 5. The longest side is 6. So we'll have 16 plus 25. This is 36, the other one. So 4, 5, 16 plus 25, that's 31, 41. Now, you check. The sum of two shorter sides is equal for the right triangle. For the obtuse, the sum is less than, the longest side is greater. While for the acute, the sum is greater than the longest side. So let's complete now our sentence. Now, let me first clear. A right triangle is right if the square of the longest side is, that should be, is equal to the sum of the squares of the shorter sides. A triangle is obtuse if the square of the longest side is greater than. And the last, a triangle is acute if the square of the longest side is, you see, less than the sum of the squares of the shorter sides. So again, if the square of the longest side is equal to the squares of the shorter sides, then it's a right triangle. If the longest side is greater than the squares of both, it's obtuse. If the square of the longest side is less than the sum of the squares of the shorter sides, we say it's an acute triangle. Let's have another drill. We're almost done. Determine whether a triangle with given sides is acute, right, or obtuse. Actually, we start with the Pythagorean theorem still. C squared is what? C squared, is it equal, greater than, or less than to a squared plus b squared? C is our longest side. That's 8 squared. We're checking what's the relationship of a 4 squared plus 5 squared. 64. It's going to be 16 plus 25. So 64 is greater than 41. If you check, 64 is greater than 41, I mean. So we say that the triangle is obtuse. Next, let's go to the next one. A is 10, B is 15, and C is 17. Ready? we have c squared. We're finding the relationship of a squared plus b squared. Our c is 17, we square that. Our a is 10, we square, plus our b is 15, we also square that. 17 squared is 289. What's the relationship of 100 plus 225? So 289 is less than 325. If you see the longest side, its square is less than the squares of two shorter sides. So we say that the triangle is acute. Let's go to the next exercise. A is 5, B is 12, C is 13. Again, we do the c squared. What's the relationship of a squared plus b squared? Our c is 13, we square that. Our a is 5 squared plus 12 squared. So we have 169, the relationship of 25 plus 144. So 169 is equal to 169. If you see, the square of the longest side is equal to the sum of the squares of the two shorter sides. So we say that the triangle is right. This ends for the part 1, and I'll have another video for the part 2.